were working on these problems yesterday. We stopped, right, we got through example 4. So I'd like to do maybe 3 examples today. And then
Is
give
this
you
a
guys some
bearing
time.
problem?
Less complicated than bearings.
I don't remember. I can't do bearings, so.
Okay. Car A is traveling west at 50 miles per hour. So, car A.
Triangle.
Okay, moment of truth. Which way would I go if I'm traveling west?
Oh my gosh. North.
Okay, so it's traveling that way. Car B is traveling north at 60 miles per hour. Did I say they started at the same point?
No.
No. So I just know that car B was somewhere and it's going up. Ooh, can't draw a straight line. Okay. So car A, car B. What would these be?
That would be the derivative.
So I'm going to call the distance A has traveled as A and B is B. So I'm going to say my dA dt is 50. My dB dt is 60. Both are headed for the intersection of the 2 roads, so they're going to meet. At what rate are the cars approaching each other? So where would that be when they're approaching each other? What am I looking at? C, that's the distance between them. If I want the rate, that would be
dC over dt.
So that's what I'm trying to find. When car A is 0.3 miles and car B is 0.4 miles from the intersection, what are those?
That's just your regular.
So A is 0.3, B is 0.4. Alright, what next?
Gotta put that in here.
Okay. Alright, so derivative of A squared would be derivative of B squared derivative of C squared. Nothing was constant here because all these sides are changing.
We gotta find our C with our.
Yes. So we can come up here, we need C, so we know 0.3 squared plus 0.4 squared plus C squared. So C is 0.5 at this instant. So then we can plug it in everything. A is 0.3. dA dt is 50. B is 0.4. dB dt is 60. C is 0.5. We don't know dC dt.
Can you show me real quick? This is like kindergarten math. How you multiply 0.3 and 50? Like how you?
I did 2 times 0.3, which is 0.6 times 50. And so when you multiply those, if you do 6 times 50,
300 over 10. Okay.
and then you
Or 2 times 50 times 0.3 is 30.
multiplications can you do it, doesn't matter what you multiply.
Oh yeah.
Alright, and what would my units be?
Mile per hour. I was really confused. I almost just asked if Grayson wasn't here. I sit with him at lunch.
Where is Grayson today?
I don't know. Him and Tyler are both gone.
Interesting.
I
Crazy
know.
for one.
I know.
There, isn't it?
try setting up this one. See how far you can get.
What is the word that has been? Oh, it's on the board. Never mind. The double hole punch got rid of the word. It's like.
If anybody wants a room temperature soda, there's a few left from the Christmas party. You just can't tell my class that anyone else that I gave you one because I have lots of people hounding me for them. I don't have enough for all my classes, but I'll give them to you guys because you're in calculus. If you want them.
Just for a lesson.
We're in California. She's amazing. You want Dr. Pepper, Caleb?
Was flying a kite on a string. So we have a kite. I am very. There's my kite. Okay. The kite is 120 feet above the ground. So that is like our height, right? So that's 120. And the wind is blowing the kite horizontally away from her. So the girl's down here, the kite is being blown horizontally
Oh.
at a rate of 6 feet per second. If it's a rate, that's a derivative. If I'm going to have a derivative, I need a variable here. So that's, let's call it x. So that means my dx dt is 6. At what rate must she let out the string when 130 feet of string has been let out? What is that talking about? The hypotenuse. Your string is going to be your hypotenuse. So the girl's standing down here, her kite went up, now it's floating this way. And as it floats, you have to let out more string, right? So if I call this side y for a second, I know I'm looking for the instant when y is 130, and I want the rate, so that would be dy dt. Okay, is this 120 changing? No, so I don't have to worry about a rate or a variable there. So we set up Pythagorean theorem. X squared plus 120 squared equals y
Oh,
squared.
so you don't put a 0 in.
So now what do I need to do?
Derivative.
Okay, derivative of x squared would be
Sure.
x dx dt. Okay, 120 squared,
0.
derivative of that is 0 because it's
Wait,
constant. Derivative of y squared would be,
2y dy.
do I have all the information I need to plug into here?
No.
We need x, so we can do x squared, 120 squared equals, at the instant we're looking at 130 squared. So the instant we need x is 50. So we plug in, x is 50, dx dt is 6, 2, y is 130, dy dt. Over 13. How many units? Y was measured in feet, and t, time, was measured in.
I don't even know what I was trying to
So
do.
it wasn't even
Like,
that bad.
That was just worded really oddly.
I don't like the areas of circles and like the volumes. And I don't like those questions.
I don't like 3D shapes.
I'd rather have triangles.
On to example 7.
Onto this one with this water tank. Cylindrical cone.
Yeah, I might do these out of order. I think I might
Love you.
save this one for tomorrow and do example 9 today. So tomorrow we'll do 7, 8, and 10.
A man 6 foot tall.
So, a man 6 foot tall walks with a speed of 8 feet per second away from a streetlight that is atop an 18-foot pole. So, I have a light on top of my pole, and that is 18 feet tall. Does that height change? Okay, then I have my man walking away.
Gonna label this guy CJM.
And he is 6 feet tall. Does that height change?
No.
Okay. So if he is walking away, he is going this direction. Would we agree with that?
Mhm.
So man 6 feet tall is walking with a speed of 8 feet per second. Okay. We want to know how fast the tip of his shadow is moving along the ground. Where is his shadow?
Behind.
Red sand.
This is his shadow right here.
Oh.
Okay, so
Oh, I see. Okay, I understand.
pretend this all worked out for you. Okay, here's my triangle. All right, we have a couple issues here. My speed that I'm given is how fast he's walking away. So that means I need a variable for the distance he has walked away from the streetlight. Okay, so from here to here, the distance he's walked away, I'm going to call that a variable, so maybe x. And if he is walking at 8 feet per second, that means my dx dt is 8. We want to know how fast the tip of the shadow is moving. His shadow is related to how far away he's walked. So instead of just calling this little piece y,
Y plus X.
I think it would be easier to think of y as the entire length of this triangle. You could do it the other way, but because I have the rate of his shadow is what I'm trying to find, I really want dy dt. And so this is actually going to be a little bit easier later on if we set it up like this.
I believe you.
And we know the instant we look at x is 100. All right. I think I left you extra space here. This might be one where you need it. Do we know? Do we have any ideas here? This really wouldn't be a Pythagorean theorem problem.
X, Y, Y.
We can make a triangle.
It looks like
We
a
can
triangle
always
to
make
me.
a triangle.
Okay. We really have how many triangles
Two
here?
triangles.
Okay, so if I separate them, aren't these similar triangles?
Oh, it's like
Are they?
a relativity. That's not what it's called.
I get a proportion. This is why I wanted that side to be y here. I think it'll help a little bit. So in this triangle, this height is 6. What would this length be?
A third of Y.
Not necessarily,
No.
because it's
Y
changing
minus
as he moves.
Oh.
Right, because he's walking.
Yeah, I just was like looking at it, you know.
Okay. So we can set a proportion. 18 over y plus 6 over y minus x. I don't really want to do the derivative from here. Can I cross multiply first? Like, the more I can simplify, the better it's going to be for me. So 6y will equal 18 times y minus x. We could simplify this a little more if I brought over my y. Negative 12y is equal to negative 18x. Divide by negative 6, so 2y equals 3x. I didn't necessarily have to simplify this much, but that's a little bit easier because now that's a pretty simple derivative, isn't it?
Mhm.
Derivative of 2y would be
2 dy dx.
2 equals 3.
2 dy dt
That's what I
equals
meant.
3. Right, dy dt is what we're trying to find. Dx dt is 8. Dy dt is 12. What would my units be?
Feet per second.
Yeah, if I did that alone, I would not have got there.
Yeah, no.
Oh, you would have, given enough time.
Yeah.
Give it enough
5
time
years.
and an infinite amount of typewriters.
Is there another way to do this?
Yeah, there are
Oh.
other ways of setting it up.
Just let me get through college real quick.
Come back.
Let me get my minor in math and I'll be back.
Yeah, for sure, for sure.
All right, I want you to try some more.
Okay, I'll finish these